Okay, guys, I think this is going here. It's just notes for 4.3. A lot of people have already seen this. Actually, if you're watching this video, you probably haven't seen this part of it because you weren't in class. So we're talking about systems of equations using other methods. We're going to talk about a form of substitution called equal values, and then on the back here, we'll talk about just a couple simple elimination problems here. So we got Eliza and Jenny. They want to sell the most handmade bracelets for a school fundraiser. Eliza had already raised 150. Jenny has already raised 80. Eliza decides to sell her bracelets for 2, and Jenny decides to sell her bracelets for 3. At what point will they have made the same amount of money? So I want to define my variables. I'm going to have x and y. X is going to be the number of bracelets sold. Sorry, can't think. It's the end of the day here. Number of bracelets sold, and then Y is the amount of money made. Let's say total amount of money that each of them makes. Okay. Now we're gonna have Eliza kind of on the left side here. We'll have Jenny on the right. So they're each going to start with y equals here. Okay. Now this type of equation is going to be in the form of y equals mx plus cb. We call this slope-intercept form because we have our y-intercept here, is where it starts, and we have our rate of change or our slope right here. The reason I'm choosing this type of equation is because if I look at like Eliza right here, I have that 150 bucks is the y-intercept. Okay. And then I have the rate of change at $2, which is going to be applied to that x, the number of bracelets sold. So Eliza's selling her bracelets for 2. So that's y equals 2x plus 150. Jenny's is going to be set up the same way, except her numbers are different. She's doing $3 per bracelet sold, and then she started with 80 bucks, or she already raised 80. So the idea here is we're going to substitute one equation into another. When it's equal values is what I call it when it's both set up in y equals mx plus b. So the idea here is I'm going to take this equation, or this part of the equation, and this part of the equation, and put them together because they're both equal to y. So the idea here is that I'm taking this 2x plus 150, and because it's equal to y, I'm substituting it in for that y. So it's 2x plus 150 is equal to 3x plus 80. Now what I've done is I've taken these two equations that each have two variables, so they're unsolvable, and because of the combination of them, I can substitute them to basically eliminate the y and substitute it with an expression that has x in it, which I can solve. Now I take the x to the left side. 2x minus 3x is negative x. I'm going to subtract that 150 over here because I want my numbers on the right. I get negative x equals negative 70. That's a negative 1, so I'm going to divide by negative 1 on both sides, and I get x equals positive 70. So that's the number of bracelets sold, and now we got to figure out the total amount. So the idea here is I'm going to take the 70 and plug it into one of these equations. I'm going to do Jenny's first, so I'm going to do y equals 3 times 70, right, and goes right in for the x because it is x, right, plus 80. 3 times 70 is 210, plus 80 gets us 290. Now you might be like, oh, why did you choose Jenny's equation to plug it into, Mr. Wishart? Okay, let's try Eliza's then. So I take the 70, I do the same thing, right? I take y equals 2 times 70 plus 150. That gives us 140 plus 150. And I add those together, and I end up actually with 290. Oh, look at that, same thing. So the moral of the story here is that it does not matter which equation you choose to substitute. Good Lord. It doesn't matter which number you choose. Let me start over. It doesn't matter which equation you choose to substitute in, you're going to get the same answer. This is your x value, this is your y value, so your solution is here, 70, 290, but it is a word problem. So we need to finish it off with a sentence, right? So at what point will they have made the same amount of money? If they sell, let's say each sell 70 bracelets, they will each make 290 bucks. Okay, cool. Same thing here, but this isn't a word problem. So I take this 4x minus 7, and I set it equal to 3x plus 8. Again, I take the x to the left side, cancel it out here. 4x minus 3x is 1x, or x. And then I take the 7, and I'm going to add it. And that's the inverse or opposite of what's currently happening. I'm going to shift this up a little bit. I get x equals 15. Halfway done, because I have my x value and I need to find my y value. So I just got to plug it into one of these. Again, it doesn't matter which one, because we'll get the same answer for either one. I'm going to choose the second one. So it's going to be y equals 3 times 15 plus 8, which is 45 plus 8 is y is 53. So our answer for this is 15 comma 53. That is our answer. And we're good here because this is not a word problem, so it's just asking for the solution. So we don't need to like summarize with a sentence or anything like that. So we're done. Okay. Now here, same thing, right? They're both y equals mx plus b, so I can set the right side of each equation equal to each other, right? If you were thinking ahead, you might start thinking that this is a little bit weird, right? And you'd be like, 6 doesn't equal negative 8. Have I done something wrong? No, you haven't, right? The idea here is that, let me get Desmos up so I can show you what this looks like on a graph. Because, you can graph all of these problems to do this as well, to figure out solutions. But if I don't give you a graph, then it's harder, right? And so I'm going to put my equations in here. It's going to be y equals 5x plus 6. And I got y equals 5x minus 8. And I can see that they're parallel lines, right? And so the idea here is that since I have the same, let me go back here. The same slope, but different y-intercepts means I have no solution, right? Because the lines are parallel. That means they don't touch, right? Lines don't touch. That's just basically the definition of being parallel. They have the same slope and different y-intercepts, right? So when you see that combination of same slope, different y-intercepts, you know that it's going to be parallel, so there's going to be no solution. Okay. Okay, now we've got a different method of solving. This is going to be elimination. Simple elimination, because it can get more complicated, but it is it's a simpler version of a problem. So we got these two kids. Carlos and Nick went to a bake shop to benefit Mr. Wishart, who wants to go to Fiji this summer for vacation. Carlos bought 24 muffins and 15 croissants for $3.48. Nick bought 24 muffins and 20 croissants for $4.08. 4 bullet points here. I want 4 bullet points in your answer, okay? So first bullet point is create a system of equations that can be used to determine the values of x, the price per muffin. I like to define my variables, even though it's technically defined right here. And the price per croissant, y, the price per croissant. You got to say it in that French accent, otherwise it's, I don't know. Yeah, I'm sorry. I don't know why. All right, so our first equation is going to be Carlos. Carlos brought 24 muffins. Muffins is attached to x because that's the price per muffin. And 15 croissants. 15 is attached to y because I've defined it to be such, and spent $348. I'm adding because it's totaling up to this cost right here, or this price right here. Nick is the same way, except he's got 24 muffins, so he's got 24x plus 20y equals 408. Yeah, I mean, similar logic right there. So, boom, I've created my system of equations. I've got an equation here, an equation here. Now I'm going to state the price of a muffin, price of a croissant, and then show or explain the steps. I will show rather than explain because I just want to show my math and I don't want to have to write it out, okay? If it just said explain, you would have to write out your answer or explain the steps basically in sentences rather than just showing the math. But anyway, the idea here is I'm going to take my equations plus 15y equals 348, and then 24x plus 20y equals 408. The idea here is that we want to eliminate a variable so that it becomes easier to solve. Because if I just look at one of these equations, like this first one right here, it's got 2 variables, so I can't solve it, but by combining them, I can kind of eliminate a variable. Now what I'm going to do is I'm going to subtract one equation from the other. 24x minus 24x is 0, so it's gone away. 15 minus 20 is negative 5y, And then 348 minus 408 is negative 60. I'll divide by negative 5. And I get y equals positive 12. So I've just figured out the price of a croissant because I know that y is 12. Price per croissant is y, so that's $12. However, muffins are first in the order here, so we got to figure that out before we kind of summarize. So what I'm going to do with this 12 is plug it into one of these equations. You want to choose the easier one. I think 20 times 12 is easier than 15 times 12, so I'm going to use the second one. So it's going to be 24x plus 12, right? 20, my bad. 20 times 12, the y goes away, becomes this 12 equals 408. 24x plus 120 is 408. Is this right? 240, my bad. There we go. So we're going to subtract 240. We end up with 24x equals 168. We divide by 24, and we'll get 7. That's the price of a muffin right there. I know it's muffin because x is price per muffin. I just link those up. So now I've got my second and third bullet points. I know muffins first, so I'm going to say muffins are each $7. Yeah, okay. Muffins cost $7. Right. Croissants cost $12. I'll go here and I'll be like, boom, boom, got it. 3 bullet points so far, 3 bullet points in my answer. Show or explain, I can just say see above for work, or my work is shown above, whatever, right? Just some way to indicate that you've done it. Again, I could write this out. I could be like, well, I took my equations and I subtracted to eliminate the x's, and then I solved for y, and then I took that answer for y and plugged it in the equation to get x. You know, you could do that if you wanted to. Simple elimination here. I'm going to do the same thing. This is just a kind of a simpler problem without the word problem associated with it. We're going to subtract here. That's going to give you 0. 6y minus 2y is 4y. 12 minus 20 is negative 8. We'll divide by 4. Get negative 2. Take that and plug it in. Again, doesn't matter which one. You get the same answer. So 4x plus 6 times negative 2. We'll just do the first one. That's negative 12. We're going to add 12 on both sides. 4x is 24. We'll divide by 4 to get 2. 6 for our x. 6, negative 2. That's our solution. Again, I don't have to write a sentence about this like I did over here because it's just a problem, not a word problem. Okay, here, distribute, whenever you see parentheses, right? You want to do those first thing to get rid of whatever is on the outside, if you can. So this becomes negative 6x plus 10 equals half of 12 is 6, half of 4 is negative 2. Now I'll combine these two together to get to 4. So negative 6x plus 10 equals 6x plus 4. I'm going to subtract this 6x. I'm subtracting because it's positive. Comes over here. Yep, cancels out. Negative 12x plus 10 equals 4. We'll subtract 10 here. I'll bring it over here. Negative 12x equals negative 6. We'll divide by negative 12. Since we're dividing by a negative, the negatives cancel to become a positive. So I end up with 1/2, and that's our answer there. Ta-da!